and Commerce, Vashi. It gives me immense pleasure to welcome you on second day of Faculty Development Program on Research Methodology, Statistical Testing, and Data Analysis using MS Excel. Let us pray Lord Ganesha before starting the program that he will definitely remove all obstacles in our lives. Om Ekadantaye Vignahe Vakratundaya Dhimahi Tanno Danti Prachodayat. We bow before the one with the single tusked elephant tooth to illuminate our minds with wisdom. Dear friends, this 100 nanometer COVID 19 taught us many big lessons to all the people in the world. Nature warns us that you are not my masters, all of you are my guests on the earth and live like a guest. The rapid spread of COVID 19 in India has pursued us to work with caution towards change. COVID 19 enables us to think about all kind of research and its impact on each and every field. Friends, research is a careful study of something to find out information. Information is a processed data, whereas knowledge is information that model to be useful. Example, Google or Google Maps only contains information, not knowledge. For acquiring knowledge, you have to do sadhana for the rest of your life to achieve the perfection in your life. I would like to talk on Prime Minister Narendra Modi's speech. He addressed in his speech that Atmanirbhar Bano, be self-reliant. 150 years ago, Swami Vivekananda said, we want that education by which character is formed, strength of mind is increased, the intellect is expanded, and by which one can stand on one's feet or arise, awake, and stop not till the goal is reached. Both the sentences have same meanings. Innovation is taking two things that exist together and putting them together in new way. What is calculus of innovation? It is knowledge drives innovation, innovation drives productivity, productivity drives economic growth. Research and innovation is a part of economic growth. As a part of this, researchers have to be involved in exploring new theories, practical applications in real life, and futuristic development of new product and services, etc. On behalf of Tilak College of Science and Commerce, I would like to give my sincere thanks to Dr. Shraddha Bhume Madam for yesterday's insightful presentation. Thank you, Madam, for addressing for the faculty development program. I hope many researchers have planned their thesis yesterday itself. Many of you also have planned your major and minor research projects also. Today, I would like to invite Dr. Sakharam Mule sir from Kishan Chand Chelaram College of Science and Commerce, Churchgate. Today, he will discuss on introduction to hypothesis testing, basic concepts of concerning testing of hypothesis, and understanding standard different parametric test. I would like to welcome Dr. Mule sir on behalf of Tilak College of Science and Commerce. Sir, please guide us, our researchers. Thank you very much. Over to Sheetal for further program.
Thank you, ma'am. On a delightful evening to all the faculty members present on for the workshop of Faculty Development Program on research methodology, statistical testing, data analysis using MS Excel. On behalf of Tilak College of Science and Commerce, Vashi, I, Professor Sheetal Aditya, the HOD of BMM Department, deem it's an honor and privilege to propose the words of gratitude for being with us this evening and making us feel proud, and even more above all your inquisitiveness towards acquiring knowledge. Before we commence, I would like to express with a high sense of gratitude to our chairman, sir, chairman of Tilak Education Society, Sri Jayan Kurup, sir, and eminent educationist and an inspiration for many people for awakening their desires and wonders, and all the people who are associated with teaching fraternity. Thank you, sir. I would also like to express with great sense of gratitude to in terms of to the faculty members for giving us monumental reviews and views for our first day program that we had with Dr. Shraddha Bhumi ma'am. With around 5,000 views till now, it's a massive response that we've got. So thank you so much to all the faculty members for making this program the first day so huge and successful. So today, so let's create another monumental record of your participation for our next guest that we have today. Um, the guest that we have today is going to address more on statistics. As we know, most of us would have known that statistics is all about numbers and data, but it's an array of knowledge and procedures that allow us to learn through data reliably. It's a crucial process today. Why? Because many discoveries of science and many decisions which is based on data, many predictions that is very critical today is all analyzed through data. A very skilled and an accomplished statistician does not need any introduction, but his analytical, his technical, his critical skills does the job. So we have with us our guest today, that is Dr. Mule sir. Thank you, sir, for being the part of this session, and presiding over as a panel for the speaker. A few words about Dr. Mule, sir. Sir is now currently working as an assistant professor in the Department of Statistics with KC College, Mumbai. He has a massive teaching experience of more than 15 years of private as well as government aided institutions. He's also visiting faculty with different institutes such as Bharati Vidyapit Institute of Management Studies, Dr. D.Y. Patil Institute of Navi Mumbai, Department of Statistics, Mumbai University. He has been across a panel for a workshop under training for for across a lot of UGC projects, which are some to quote is the NAC accreditation programs that he has done. He's been a panel member and for workshops as a resource person for training in SPSs across very lot of across sessions which are all across India. Especially one to mention is the Pune session that he conducted. Yes, he has been a part of major as well as minor UGC projects. And I just wanted to say, sir, that we are very privileged to have you, and we just want to explore the knowledge of data analysis from you, sir. So we'll just let sir take the panel. Welcome, sir. Yeah, sorry for the technical thing. Uh, we have with us, sir. Sorry for the interruption. Please bear with us. There's a technical glitch here.
Am I audible?
Yes, sir. Yes, thank you. Yes, sir. Thank you, sir.
Shall we? Yeah.
Yeah,
Thank you for such a inspiring word. And I
oh,
would like, I
sir.
request you to share my presentation so we can directly start
Yes,
our session for today. Because there,
yes.
as you said, that there are so many people who are waiting and they are keeping their time reserve time for this particular session. So we should not waste our time and we should go for our session. Please share my presentation. I welcome all the participants and all the dignitaries for this particular workshop. And I'm very happy that yesterday there was a session on research methodology, and I think the research methodology session was talking about how to plan your research. So yesterday you must have discussed so many things, that how we generally we plan a research. And when we are talking about research, it is mandatory for us that we should think of so many things. That means starting from how I should open my topic till how I can close my topic. So that is a complete opening and closing of particular contents. Nowadays there are so many research which are happening around, and all this research has some speciality into it, and most of these research are planned under certain assumptions. These assumptions basically, when we write a chapter of research methodology, as in case of while doing your projects or PhDs, or when we are talking about, or when we are discussing research methods, in case of in particularly while writing a research papers, in that case we have to talk about that how this particular research has started. That means what was the idea, and starting from idea, then benefits to the society, then how the sample for the sample for the research will be collected or has been collected, and then how it has been analyzed. Okay, and also this research method also includes that what are the hypotheses which are being tested. Okay, when we talk about this particular type of studies, there are two types of studies. Basically, I categorize this whole research into two categories. The first is, we say that where there is no hypothesis and I want to explore my information, and second is, we call it as a guided research project. And who is guiding this particular research project? It is the hypothesis which is guiding research project. So when we are talking about research, and particularly hypothesis or hypothesis based research, in that situation we have to think of hypothesis very strongly, because this hypothesis ultimately takes us to the end or conclusion of our study. If we fail to write a particular precise and objectives hypothesis, in that situation we may not be able to conclude our study. So that's why when we are going through many research projects, so at that time we come to know that where is the problem, that why the students are not able to come out with some conclusions, or not able to give certain suggestions, or not able to come out with some strong suggestions. And when we retrospectively study their synopses and everything, so at that time we come to know that there's a problem in the hypothesis, because something which is assumed is hypothesis, and accordingly we frame our hypothesis. So at the beginning, when we start a study or when we start our research, at that time we are very curious about research and curious about our topics, and we try to put an hypothesis which may not be testable. In that situation, when you start collecting data or when you start your research, at that time once you have collected data, you come to know that most of the hypotheses which you have planned, they are not testable. So the problem is that research, the hypotheses which are particularly taken into study, they have not thought properly thought, or not taken properly at the beginning. So that is the issue of hypothesis. So yesterday all these things must have been discussed, that how to frame your hypothesis, then how what is the importance of hypothesis, what is the importance of objective. And in continuation of yesterday's session, I am continuing in how once you have framed your hypothesis, then how I can go for testing of hypothesis. Next slide. It is very interesting to I'm starting with my slide, and my slide says that I should it titled as identification of variables of study. And I think that everyone who is doing the research, I feel that whenever they have planned a single line, when they come out with a topic, and that is a single 2 3 4 line topic, and at the beginning of topic we are not thinking too much on topic. Okay, but topic is the research topic is the only guiding for number of variables for us. Okay, so identification of the variables of study is become a very essential factor as long as this particular research is concerned. Now we can think in other way around, that if suppose a particular research we have started, and let us say that I want to now in the COVID situation, I want to find out that what is the impact of COVID on customers buying behavior, that whether that it has changed because of this COVID situation, or whether it has been, or whether it is same as before COVID situation. So definitely this particular research when we are talking about, so this particular statement we are making about this particular research or research topic, in that situation we have to think of two situations. One is first aspect of the particular topic is that what is the impact of customers buying behavior, impact on customer buying behavior. So the word impact is very essential, buying behavior is very essential, and before and after COVID situation is very essential. So accordingly I list out all those variables, and I try to identify my variables as dependent, independent, latent, and confounding variables. So of that, most of us are very much aware about dependent and independent variables. Dependent variables, if you see that dependent variables are those variables which are expected to change their values with respect to change in the values of the other variables, and we call that variable as a dependent variable. So any research topic which we are dealing with, it always has some dependent variables, it always has some independent variables. That means I cannot say that I just have only dependent variables and I just have only independent variable in my study. So definitely when we are planning a study, it is a mixture of all these variables. If you see that sometimes some variables which we are talking, they may not be they cannot be expressed directly, but they require some other variables to express them. Say for example behavior cannot be expressed directly. That means if I want to identify a behavior of the person, then I list out some parameters which can explain the behavior of particular person. Now that particular aspect of variables which are supposed to express other variables, we call them as the latent variables. So when we talk about dependent, independent, and latent variables, dependent and independent is one category, latent is another category, and confounding variables, I have written it as it is most important to identify for any kind of research. So independent variable, when we are talking about independent variables are those variables in my study which are expected or which are responsible for happening a change in the dependent variables. So I call them as the independent variables. Sometimes there is a sequence of dependent and independent. Some independent variables are also dependent on other variables. So I have a sequence of dependent, independent. That independent again become a dependent on other variables. So that is again a dependent. So that means according to my hypothesis, I have to identify these dependent and independent variables. What I'm talking about is the very next variable, and which is a very essential variable, and we are calling it as a latent variable. Now latent variable is a variable which is say for as I said that behavior of the person. So behavior cannot be directly it can be observed by different different parameters. Let us say that how the person behaves in different situations. So we give different situation to for that particular person, and on those 5 6 situations I am able to identify that how that particular person's behavior is. That means so many times we say that he is very good friend, or he is very nice person. So but that nice word is very difficult to explain directly, and there are situations or there are variables which are actually explaining that nice of that particular nice variable of that particular person. That means how nice, that is a different question, but at least nice can be identified by from different situations. So you are saying that when we are saying that the particular person is very nice person, in that situation we must have observed him in some different situations. That we say, for example, how he behaves with you, how he behaves with other, how he behaves with you in different situations, when you are in problem, when you are in trouble. So that particular things are responsible for, and behavior of that particular person in those situations makes you think about that particular person, and to comment that he is very nice person. And the parameters which are, which can, or which cannot be, we say that which cannot be observed directly, or which are a response, or which are being derived from other observation or other parameters, we call them as the latent variables. Nowadays you will find that most of the research which is happening in commerce, it has a psychological component or behavioral component or social component. So all these social behavioral psychological components, they are the most of this research has most of the variables as a latent variables. So that's why framing of these latent variables, identification of all the parameters of the latent variables, and very critically putting a statements across or in a questionnaire about those latent variables become very essential while framing out the research. That's why it is very essential that I must be able to identify dependent variables. As such, I number of dependent variables and which are those dependent variables, and independent variable on which they are depending. So those independent variables has to be studied very properly. Then I must have to decide on that how this dependent and independent variables will be measured. That means how everyone, how one is going to have, or how one is going to uh, measure the dependent variable and independent variable. If you fail to do that, then that is measurement of wrong measurement or a wrong scale for dependent or independent variables can put you in trouble while concluding or going for a test statistical analysis. So that's why I have given a full slide and which is talking about dependent, independent and latent variable. The last point is very essential from my perspective, because I have seen a lot of research papers, I have seen a lot of theses. So from all these theses, when we try to conclude, and at that time we fail to means we are getting some absurd results. Okay, at that time what happens, that person say, for example, I am very simple example we are putting before you, and that example is nothing but it is talking about that we can say that activity and let us say that weight of that particular person, that whether the person is taking exercise every day, and weight of that particular person. Now weight of the person is, I can call it as a dependent variable, and activity or exercise done by a particular person or one person is to be considered as a independent. And we are seeing that this activity or exercise is going to have a direct impact on the weight of that particular person. Now if you see that I have collected a data, and the data is being collected from age 18 to 50, and I may get a results, a very absurd results, that is that weight is not showing any relation with the activities. Okay, because there's one variable which may create a problem, and that is the age of that particular person. Another example which we can say, that bone density and age. Okay, bone density and age. Now I have a domain of male and female, and bone density is likely to change with respect to age. But if you see that bone density is also depending on some other parameters or some other a few variables which are expected to have an impact on this particular relation. Now that means we consider we should be able to identify confounding variables at the beginning of the studies, that these are my confounding variables. This can create a problem to my hypothesis, and I have to put them in very proper way so that I will be able to come out with a very accurate conclusions. Ultimate aim of all research is to give or to have accurate conclusions or precise reasoning for the hypotheses or assumptions which we are making. So that's why it become very essential that everyone who is taking up any kind of research, that they should be able to identify dependent, independent. I've added as latent variables, that means which cannot be measured directly. There are always some variables which cannot be measured directly, but which are because of some other variables or other parameters, and then confounding variables which is very essentially, and most of the students or researchers who is doing research, they do not identify these confounding variables, and they do not even think, and at the end they are thinking of confounding variables. I'm asking you to understand or to identify them at the beginning. The reason is that you can plan your experiment very well if you know that which are the confounding variables. That means you can control your sample size accordingly, or you can have changes in sample size. You can allow more samples of that particular domain to enter in your sample size. So that whole thing can be is possible if you are if you have identified your variables as confounding variables. Next slide, please. Basic definition when we talk about hypothesis, basically hypothesis is nothing but it is assumed a formal statement about problem. Now you can see that now I'm saying that it is assumed formal statement about problem. No problem is if I want to make a very formal statement about my problem, I should be able to give a very precise problem of my study. Precise problem of the study means, that means what I want to study, there should not be any vagueness in the statement of the problem, because statement of the problem leads to the formal formulation or formal statements about that particular problem, and those assumed formal statements are nothing but the hypothesis. If you see that most of the formal hypotheses or formal statements, they are precisely there are so many books which are saying, that's why if you are coming for this particular session, then there should be something which we can call it as a take home. And I know that most of the participants who are participating in this particular workshop or FDP, they have read something about hypothesis. They may be knowing more than me about hypothesis and all, but that's why I try to put my presentation in some different way, and I have devised my presentation from the perspective of research only, not from the perspective of what the books of the statistics are saying. We have tried to devise it in some different way. Now most of the books which are talking about types of the hypothesis, they call it as null hypothesis and alternate hypothesis. Then they talk about simple hypothesis and complex hypothesis. These are the statistical hypothesis. And from the research perspective, when a researcher is thinking, so researcher has a thought on this particular research, and he always has to say that uh, what he is going to test on. So generally he has a mixed type of hypothesis in his study. He may have any or both of these both of the types, or all the types of my whatever I'm going to present here, or he might be having only one type of hypothesis amongst all these hypotheses. So that means, from the perspective of any research problem, we say we categorize a research in as per research hypothesis. I categorize it as it is designed for testing the differences. I please next, just click enter. So it it is example is, that means there are two things, two types of hypothesis we have mentioned here, and the first one is testing for differences, and second one is testing for association and relationship. Most of the research which is 80% of the research studies or researchers who are planning their research, they are basically looking for these two basic categories. That means either their hypothesis is designed for the purpose of testing for differences, or for the purpose of testing of association or relationships. So that is very essential. And we are mentioning the example is very simple example, and which is very I think everyone is aware about all such a type of examples. So I thought that I should continue with such a type of examples, because everyone can imagine about these examples. To test the significance of difference between consumer satisfaction level under different conditions, like male, female, different age group, etc. And also whatever example I cited, that is before COVID situation and after COVID situation. Now the problem statement is very clear, that I want to find out the difference, and my study is planned to find out the consumers or customers satisfaction level, and there are different conditions for this particular uh, consumers. And what are the conditions? Now you can see that I can say that male, female, and different age group. Now how to identify what is my dependent and what is my independent variable in this particular case? Now to test the significance of difference between consumer satisfaction level under different conditions. So different conditions, I can say that satisfaction level is my dependent variables, and my independent variables are gender is my independent variable, then age groups are my independent variable, COVID situation is my independent variable. Now these are the two major categories. Now can I say something about latent variable in this particular case? So absolutely yes. Okay, because satisfaction level cannot be measured directly. And how you will measure satisfaction level? Satisfaction level has to be measured on the basis of by citing different parameters. Satisfaction for any product. So if I'm talking about the satisfaction for the product, you will find that everyone who is handling any product, he will never say that he is completely satisfied with the product. He will have some problems with the features of the product. He may have some problems with the color of the product, or some other parameters might be there. So we can say that on different aspect there will be a different satisfaction. So I can say my satisfaction level is a variable which cannot be observed directly, but it is because of some other satisfaction on different features of that particular product, and hence I can call that satisfaction level as a latent variable. Now what are my confounding variables? Now if suppose if I want to say that now satisfaction level, I and my independent variable is a COVID situation. That means COVID before, prior to COVID, what was the satisfaction level, and after COVID, what is the satisfaction level? Now I'm forgetting that my sample may have people with a different age group, people with uh, uh, different gender, they may be with a different income, and all these particular parameters are expected to have an impact on the relationship between satisfaction level and the COVID situations. That means satisfaction level may be affected. This relationship between satisfaction level and different COVID situations may be affected because of the gender. Male may feel that yeah, I'm satisfied, but female may not be satisfied, because they might be missing of going into the shops and purchasing direct purchasing. So they may say that we are not satisfied in the post COVID situations. But male who is having, so he may, his satisfaction level may be may be same as that of before and after. So that means gender, I can call it as a confounding variables. So in this way, when I am framing my hypothesis, every problem, every statement, every objective, I should be able to list out my dependent variables, independent variables, then latent variables, and last one is the confounding parameters. Sometimes we may not be interested in confounding parameters, but at least we should know the confounding parameters, because at the end, if we are finding out some issues with the results when we are writing, or we are getting something some strange results, at that time we can go back and check the impact of these confounding variables on the relationships of these particular dependent and independent variables. So that's how we say that testing for the differences is my first type. Okay, the same I can say that the second type of research hypothesis is testing for association. I'm talking from the perspective of research. Okay, most of the statistics books, if when you are opening, and if you'll see that what are the types of hypothesis. So in types of hypothesis, you will get null, and we are going to talk about null, alternate, and simple and composite, all those. But definitely, first of all, we will talk about the basic hypothesis or basic types of the hypothesis which we are seeing, that it is uh, testing for differences and testing for association. Now, testing for association is very interesting hypothesis, and most of the student or most of the researchers who is taking up their research, they are they will talk about, they will say something about that they want to test the relationship between the dependent and independent variable. So that is dependent and independent variable is absolutely it is depending on the relationships. When we talk about a relation, there is we also have to think association is something very interesting concept. It has a two sides on a same coin. That means one is talking about a simple relationship between variables, and there we need not have to categorize it as dependent or independent variable. And the other side of the coin is very interesting, and that is the cause effect. And it gives us a very interesting uh, information, that whether I can build a model that is a predictive model for future, so that anyone who is dealing in those with respect to those variables, he can talk or he can predict something. That means nowadays, now if suppose I would have done any research that what will be the market situation if the epidemic happens. So, and if I would have done this study some 2 year back, 3 year back, so now that study might have come out with the relationship that we would have called it as a cause and effect. That cause is a pandemic, and effect is the market situation. So that means that is a cause effect is very essential. And this is the second type of hypothesis we are saying, that this is testing for association. Most of the researchers which we are talking, they have this basic difference, or basic two categories or two types of hypothesis. I hope that everyone will agree with this, that anyone who is thinking of taking any research, he first has to uh, s- first have to talk about that what is his research type, what he is going to test, whether he is going to test difference, or whether he is going to talk about associations. In association, even he has to be very fair, and he should be able to say that whether he is going to talk about cause effect relationship, because cause effect is very well addressed, and very requiring a lot of attention, or given a lot of attention by many researchers, and they are much interested in cause effect relationship rather than only a simple relationships. My next slide, please. So this is in continuation with the types of hypothesis. These are the two types of hypothesis, and I know that everyone is aware about null and alternate hypothesis. So I'm not going in detail of null and alternate hypothesis, but my examples can make it more clear that how what is to be called as null and what is to be called as alternate hypothesis. Because we have observed many problems, many hypotheses, and most of the time people feel that they fail to come out with a proper null hypothesis. At the end, we come out we they say that their null hypothesis is rejected, and actually that has to be accepted. And then they try to find out the problem is not with respect to statistics, and we cannot, because statistics is nothing but it is these are the techniques which are designed. They are very they are not crispy techniques, they are very rigid techniques. But if you balance it that balance that rigidity from the beginning of your research, then only you can find that it is very crispy. That means if you want to make statistics a crispy statistics, in that situation you should be very good on in a planning of your experiment. So planning gives rise to increases the crispiness of the statistics. So we have two categories, and first category is null, and second is alternate hypothesis. Null is always if you see more, if you must have read in most of the books, and it is talking about that null is a no difference hypothesis. There is no difference. We call it as a no difference. Null means the difference when it is calculated should give you value equal to 0, and we call it as a null. That's why the hypothesis is to be called as null hypothesis, and definitely we call it as a no difference hypothesis. In case of my first type of hypothesis, that it is there is no significance of when I am testing a differences, my hypothesis null hypothesis becomes that there is no significance of difference between the satisfaction level when compared between male and female. So that become my null hypothesis. And what is alternate? Alternate, I have written it as not null, because in statistics alternate, when we are talking about alternate can be of two types. We call it as a one sided hypothesis or two sided or one tailed, yeah, two tailed alternate hypothesis. Two tailed is very uh, famous, that means, and very frequent hypothesis. That means you will, if you read most of the research which is happening in India, you will find that most of the null hypotheses are supported with the two-sided alternate hypothesis. That means there is no significance of difference, and people are writing the other thing, that is there is a significance of difference. Okay, and that is very obvious, because when we are combining exploratory and experimental type research word in together, if you read books on the research methodology, they differentiate what is exploratory research, what is experimental research. But it is not in a real life, it is not a practice that sometimes it is the question comes to you and people say that what is my type of research, whether it is exploratory, experimental, or any other. So when you are taking a research, or when you are dealing with some 4 5 objectives with some 7 8 hypotheses, then we never expect that you will have only exploratory or experimental type of research. So definitely it is a mixture of exploratory and experimental type of research. So when I am making some statement, and if I am saying that, I am assuming that there is no significance of difference between the satisfaction level of male and female. My, if I am very sure, now as I said, I was very sure that a female will not be satisfied. In that situation, I may frame out that males will be more satisfied than female. But that is a one sided hypothesis. You are giving a more preference to the male, that male will be more satisfied. Otherwise, I can frame it in other way around, that females will be less satisfied than male. So I'm putting it in other way around. And if I'm not sure that what will be the results ultimately, then it is better that I should put my hypothesis that there is a significance of difference between the difference of satisfaction level of male and female. So that is a combination of null and alternate. Now accordingly you will see, you will find that null is nothing but it is, and accordingly there is a one more type of hypothesis in statistics, and we call it as a simple and composite hypothesis. So simple, I will not go in detail of simple hypothesis because you will get information on simple and composite hypothesis in detail in most of the statistical books. But as long as research is concerned, you will be required to talk about null and alternate hypothesis. And a very general statement we are expecting from any statistician or anyone who is expert in statistics, that your hypothesis should be testable. I should not I should not aspire, I should not frame the words which will give some different meaning to different people. That means there are some characteristics of the hypothesis. We always say that hypothesis should be written in very simple words. Okay, any kind of research. Now I should not say ki I am doing research for let us say that if I am doing my research in for uh, for the completion of a major project in UGC. So my hypothesis should be it should have a very flowerous word, and so words, I should take care of words very precautionary. I should use words. I will never suggest that anyone who is doing a research should use a very flowerous word or words which are very powerful and trying to give us a different meaning. So that has to be uh, avoided when we are framing out our hypothesis, because when I'm taking up research, or when I'm writing my research hypothesis, and absolutely when I'm dealing research, I'm not writing only one hypothesis. I have a list of hypotheses. I may write some 7, 8, 10 hypotheses. I've seen the studies who are with 15 or 20 hypotheses. So there's one suggestion, and whatever I'm saying, they are suggestions. They are not. They are precautions to be taken, or suggestions which may be followed. I'm not saying that it has to be followed, but it may be followed to have a more focused research. Okay, so that will definitely increase the quality of your research. That number of hypotheses which are framed, they should be less in numbers. I will always suggest that they should not go beyond some 5 or 7 if your study is a very big study, and very precise or uh, very precise in terms of words and very simple in terms of words. The hypothesis should be, that means when I'm framing a hypothesis, and if I giving it to a layman and if I'm giving it to expert, both of them should tell me the same meaning, so that they will not be a confusion while analysis of that particular information. So it's very uh, it is very interesting that some of you are asking that is it necessary that I should have a hypothesis on every topic of research. No need, because I we always say that all if I'm my questionnaire should be very precise, my questionnaire should be focused, and there should be some supportive hypothesis. So if you want to address each and every corner of your research, then in that situation you will have hypothesis from all types of questions, or try to put, because any questionnaire which is having some 30 40 questions can gives rise to some 20 30 hypotheses, because there are so many confounding parameters, there are so many latent variables, there are so many dependent variables, there are so many independent variables. You may think about differences, you may think about associations, and in that way you can have I can say that a number of hypotheses which are being placed in the study, they should be very precise and are restricted to the objectives. And I feel that all objectives need not be supported with the hypothesis. There are few objectives which comes under analytical studies, and there you require uh, hypothesis. Otherwise, in case of exploratory studies, you need not some objectives. That means it is a burden on my head that I should be able to categorize my objective as whether it is analytical or exploratory. So it is always a mixture of some objectives they are of exploratory type, and some objectives are of analytical types. So exploratory type hypotheses are always need not they are not having a hypothesis. They are simply explanation by researcher about that particular topic. While as analytical type objectives, where you are saying that it has to be analyzed, that is expected to have a hypothesis. That means when I'm planning my study, I should be able to categorize my objective as exploratory objectives and analytical objectives. Analytical objectives should have hypothesis, and all those hypotheses in the analytical objectives, they should not there need not be a very uh, too many hypotheses for that particular objective. So you we have to take care of these things. Okay. Now there is one another category or type of hypothesis I mentioned, and that is a type, that is the second type, and there is that is a testing the association. So while testing the association, I may come out with a null hypothesis which says that there is no significance of association. Let me be very precise. There is no null hypothesis is of the type. There is no significance of association between dependent and some two variables. Let us say that two dependent variables. Let us say that satisfaction level uh, 1 and satisfaction level 2, that is prior to COVID and after COVID. And I want to find out that there are two independent groups. We will talk about test which we are going to use later on. So that means two dependent variables, and I'm just simply making a comment that there is no significant association between the variables. It is very interesting that I come out with many questions from different parts, and I'm seeing that people are asking that what exactly if I am saying that there is a relation. So there are two things when we are talking about. In even differences, there will be a difference, but difference may not be significant. There will be association, but the association may not be significant. So significant, and that's word significant is actually it is associated with the statistics. That is statistically significant evidences, if they are present for some in support of that hypothesis, we say that we accept that particular hypothesis, and we have some different criteria for all such a type of analysis. But in testing of association, as I mentioned, that people may come out with another hypothesis, and nowadays we have a lot of statistical tools which are they are very powerful statistical tools which is not a part of actually this particular session. There are advanced statistical tools which are used to establish or to test the association, cause effect association. You will find that most of the people who are taking up research, they have something in their mind that I will come out with some model, I will come out with a policy, and that's why they put their efforts, and they require some evidences to show that there is a cause and there is a effect, that this particular variable is the effect and this particular variable is a cause. That is their assumption at the prior, and they want to establish that assumption on the basis of statistical study. So that's why it is very interesting that how to frame this type of hypothesis. So I cannot say my null hypothesis is there is no association, and there is association is my alternate hypothesis. So if suppose if I'm saying that I'm talking about a cause effect relationship, then I can say for example, I want to test that whether the gender has a significant impact on buying or satisfaction level with respect to certain product. So whatever I have framed is my hypothesis. Now we say that there is the gender is not having a significant impact on satisfaction level. Alternate will be gender is having a significant impact on the the satisfaction level. Now the association between satisfaction and gender is established by the word impact, and impact is talking about the cause effect relationship. That means I'm not saying that impact is the only word which is talking about the cause effect relationship, but I have to choose some words which will talk about a cause effect relationship. The impact is one very frequent word, so you can think of you can think of going for this particular type of framing of hypothesis. This is very essential. Now I'm moving into the topic, and we are calling it as now how to proceed for analysis of this particular any kind of data. Now my analysis always starts with descriptive statistics. Every time people ask that what is the use, what is the purpose of descriptive statistics, and they land up with very basic tables and graphs, and they come out with some 1 or 2 lines. Okay, actually when we are talking about descriptive statistics, and you can see that I mentioned few descriptive statistics parameters or statistic, that is mean, median, mode, standard deviation, and variance. You all are aware about this. Okay, now these things tells me about that how is my skewness is there, skurtosis is there. Skewness and kurtosis are need to be tested for in so many aspects. So in that, now in this particular uh, 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 part, that is in descriptive statistics, the researcher should be very focused that I will he should be very choosy that which type of basic statistical tools I should put in my table, whether I should put mean, whether I should put median, whether mode is essential there. So I need not have to go by mean only or median. If mean is given, then it should be supported with the standard deviation or variance. Then there should be a confidence interval, and this gives me the basic idea about the distribution of my data. It is very interesting that people who are taking up uh, research, they come out with some basic data, that is frequency distribution is also one. I categorize it under descriptive statistics, and we say that we should know the frequencies. Most of the time when we are talking about the variables where we are measuring satisfaction level, or we are taking a responses on strongly disagree to strongly agree, that means strongly disagree 5 point Likert, I'm talking about Likert scale. So if I are taking a response on Likert scale, it is expected that I should have to give the uh, categorical information about every parameter, that how people have responded. That means I have to mention the percentage respondent falling in strongly agree for that particular parameter, because that gives me the idea that what is the trend of people, the general trend. I may not test it at that particular point, but that leads or that takes me that what, or that gives me the idea that what I am expecting in my statistical testing. So it is very essential that uh, every researcher should go with the descriptive statistics. And the second part of the statistics, so that means subject statistics is basically divided into these two parts, that is descriptive statistics and analytical and inferential statistics. And the point for the purpose of these two things, we have a sampling theory, we have multi that means we have design and analysis of experiment. All these are the supportive subjects, but this is a basic idea which is very much required in the market. People are searching for people who are taking up analysis, and there are very few people who can do analysis. I'm not saying that there are very few, there are so many, but anyone who want to be a very good statistician, he should have a hand-on understanding the concept from the perspective of research, and it is a skill. That's why government of India has categorized that analysis as a skill, and it is not a job of only statistician, but a statistician is not a person who is learned statistics or who has learned statistics. He is a person who know how to apply statistics. So if we have if we are talking about analytical or inferential statistics, then we have to decide on whether or not to reject or null hypothesis. Next slide please. This is these are few criterias, so I must have to talk about the criterias, that probability or test statistic value. How will you either accept or reject your null hypothesis? So you will accept or you will reject your null hypothesis, because most of us are doing analysis using certain softwares. So nowadays softwares are coming out with p values, and we did not have to go back and see the table values. So in that situation, we have to talk about. I'm going to talk about p value only, and this we call it as a decision rule. And null hypothesis decision rule with respect to p value is very simple, that null hypothesis will be rejected if p value is less than the desired level of significance. Now, what is level of significance? Level of significance is nothing but it is, we say that alpha is, we normally call it as alpha, and it is the expected, that is alpha is a maximum allowable type 1 error, and we call it as a maximum allowable type 1 error is nothing but it is alpha. And we, on the basis of alpha, we say that it is, if suppose no people are aware about these two standard alpha values, and which I have mentioned on my slide, that is 0.05, we normally call it as a 5%, and 0.01 we normally call it as 1%. So if you are very strict on your research hypothesis, then you should choose a very smaller p value. That means a smaller p value avoids or making you gives more powerful, it is very powerful, and it will not allow you to make too many mistakes on the samples with respect to population. There is something we always when we interact with people, they come out with a discussion. They say ki, if I'm saying a 5%, then what is the meaning of that 5%? 1% means what is the meaning of that 1%? So 5% is actually, it is we say that only 5 times I may not get results. Whatever I'm saying about, if you have taken any sample from the population which I have studied, that means my hypothesis or my conclusion will not be true only for 5 times. Okay, so that is the limitations we are putting on our errors, and we call it as alpha, that is a level of significance. So that is a level of significance we are rejecting. And I'm not talking about the other criteria, decision rule, that is a test statistic. If you see that it is exactly opposite, so people should not have to confuse their self that. And if they will stick to only this p value criteria, that is sufficient, because most of us are now doing analysis with respect to using softwares. So in softwares, if you are generating a p value, then p value less than 0.05, we reject null hypothesis. P value less than 0.01, then we reject null hypothesis. I've written one more thing, that it is equality. What to do with equality? Equality is absolutely a dilemma situation, and if you are a very good researchers, and if you feel, that means there comes a researcher's opinion about the about uh, his hypothesis, and but it indicates that it is at 5% or at 1%, it is not, there is no strong evidences, there are no strong evidences. So if now, how to take a judgment, or how to take a decision at this particular value, that what to do if my value is equal to the level of significance, whether I should reject my null hypothesis or whether I should accept my null hypothesis. We normally say that if it is less than 0.05, then we suggest that you should reject your null hypothesis. But if it is equal to, or it is on the, when it is a borderline case, then we suggest that we should have to go for some additional samples or some additional studies, so that we can establish a proper relationship. So that is a suggestive. But now when we are talking about when it is less than, so there are many textbooks which are referring, and they may come out with p less than or equal to 0.05, we should reject null hypothesis, or some books they may come out with p less than 0.05, we should reject. But I'm putting my personal opinion, it should not be taken as uh, you can refer, and you can take it as you wish. I personally feel that when it is at equality sign, when your p value is at equal to, then one should not conclude anything, and he should proceed for adding some more samples, and he will definitely, we call that case as a trending case. And when we call it as a trending case, that trending case may be either fall on the left side or may fall on the right side. That means either it will fall on the towards rejection, or it may be talking about not to reject the null hypothesis. That means I accept alternate hypothesis. So accepting or rejecting null hypothesis, when you are precisely knowing that it is very precise statement and you are getting a precise p value which is less than 0 point or defined level of significance. Otherwise, we should continue in study and we should collect some more samples, and we should confirm our hypothesis in that way. Now, the next thing which I have just mentioned, that what is level of significance is nothing but that is alpha is nothing but it is level of significance, and standard alphas are 5% and 1%. You can choose any one of that, and according to, if you are very strict on your studies, then you can choose you can go for choosing uh, the 1%. Next slide, please. So this is something I have mentioned here, that every test has some assumptions to be satisfied by samples collected from the population. So what researcher should do, that when he is taking up any research in that situation, he must have to go for identifying some statistical test at the beginning, at least about his hypothesis, major hypothesis. He should be able to identify some test. At that's why there is there is one gap arrangement we call it as, and that is pilot study. So in pilot study we can come out with some idea. We come out with some idea that this is it is talking about it will pilot study can me the idea with which I have to use analysis of the major hypothesis. So student or people should use by you are going for pilot study at the beginning, and there they can decide on which statistical tools they can use at the beginning only, and then they can choose the test. Okay, while choosing the test there is a criteria. Today we are going to talk about that also, and we say that every test which is being written or derived, it has certain assumptions at the beginning. So if you have identified the test, go back and check the textbooks or check the books which are written for that particular test, and find out the assumptions of that test, and find out it falls in find out where it falls in which domains. Categorize the statistical test in two domains. One domain we are calling it the parametric domain, or other called as the non-parametric. So we are most frequent till time we were very frequently use the parametric domain, and without taking any efforts of testing the assumptions of the parametric domain. So now that parametric domain has to be identified. That how will you identify parametric, whether I should use a parametric test or non-parametric test. So next slide, please.
Sorry to interrupt, sir.
Next slide.
Sir, Mule sir.
Hello. Ma'am?
So the audio is not very clear. You can be a little louder, sir.
Okay, I will be. Okay, now it is clear.
Yeah, now it's clear, sir. Done.
Now, okay, okay, done. Yeah, there might be a problem with the internet. Please, next slide, please. Yeah, assumption. These are the basic assumptions which are written in many books, and I am also continuing with those assumptions. And it is the first and foremost assumption of parametric test is the dependent variables to be measured on an interval scale. Yesterday, there must be might be a discussion about types of variables. So when we are talking about types of variables, there is another type on the basis of measurement level of variable, and we call them as normal, ordinal, ratio, and interval. So interval scale is considered to be the highest scale, and if your very dependent variable is at least on at least on interval scale, then I should proceed for my for using a parametric test. Now, someone may ask me a question: now, what to do with the satisfaction level? How will you categorize satisfaction level? Satisfaction level is nothing. Satisfaction level cannot be considered as interval scale variable, but it comes under the category of ordinal, and there we require some other domain of the test. That means I must categorize my variable. I must categorize every variable as whether it is nominal, ordinal, or interval or ratio, and then only I can proceed for choosing the test. The second is if it is if my dependent variable is observed dependent variable. Now what is my what is dependent variable? Say for example, I want to compare age. Age is a dependent variable. I want to compare profit is a dependent variable. Profit in because it is measured in rupees, so it has some certain unit of measurement. And all those in generally, if we say, if you want to remember it very generally, I can suggest you that wherever you are finding that if there is a unit of measurement for any variable and precise unit of measurement where zero is defined very properly, in all that situation you can use you can use parametric test only if it satisfy next two assumptions. What are the next two assumptions? The next is data in a sample to be normally distributed, and the next one is the samples have same variance. Normally distributed data is nothing but it is talking about. Am I clear? Am I clear now? Am I audible? Am I audible?
Yes, sir.
If I'm audible, please put
Yes,
it
sir.
in
Yes,
chat
sir.
that I'm audible.
Yes, sir. You're audible.
Just put yes. If I'm audible, just put in chat box. Okay, so we can continue. Second assumption is not very we can say that it is very important, but it is very famous assumption and everyone is aware about that. I will talk about the third assumption. If your second assumption that data is normally distributed, that means it satisfies the conditions of normality, then if you tested it using some statistical test, so and if you found that it is normally distributed, then you can proceed for the next one. And next assumption is very essential assumption, but most of the time it is ignored. And what is that? The assumption is the samples have the same variance across. Okay, samples have the same variance. Sometimes we read this but we ignore this particular, because we are not able to understand what exactly this assumption is saying. Say for example, if I have a population of 100 and if I am making a sample of 10, 10, 10, 10, 10. Okay, now I have taken some sample of 10, 10, and out of this 100 people, I'm making a group 10 groups or each of 10 people. Then, and if I calculate the average age of this particular groups, then the average age may be different. But if I calculate a variance, that variance will be I'm audible.
Yes, sir.
Okay, thank you. Now, the assumption which I am talking about is the third assumption, and that is samples have the same variables. So I have given one example that I have 100 people in my population, and of this 100 people, I made some 10 groups, and every group has 10 parameters. So I calculated the mean of the 10 groups, and across these 10 groups, I calculated the variances of 10 groups. So that is the idea about the assumption of parametric test. Hello, am I audible?
Yeah. Yes, sir. Yes, sir.
Sheetal ma'am, am I audible?
Yes, sir. Yes. So we can continue.
Am I audible, madam? Yes, okay.
Yes, sir. Yes,
So
sir.
the yes, yes, I will continue.
Yeah.
Yeah, the samples have the same variance. So I have 10 groups, and across these 10 groups, I calculated the mean age. So you'll find that the mean of the 10 groups will be different. But if I calculate a sample variance in each of the group, when I'm comparing the variances of 10 groups, there should not be a statistically significant difference between the variances of 10 groups. So that is the idea about the assumption of parametric, and that is the third important assumption. These assumptions has to be tested before choosing any parametric test, because the ultimate aim of any researcher is to give or come out with accurate results or rigid results. Rigidity is basically, if your assumptions are satisfied properly, then anyone who will test it in future, or if he collect any sample from that population, his research or his conclusion, his findings will be around your findings, or maybe near to your conclusions, or maybe near to your findings. So that's why it is very essential that you should have to test the assumptions of parametric test. uh, Please, next slide, please. Yeah, this is I think this is very interesting slide, and I divided whatever session I have discussed till, that means up to the previous slide. I tried to put it together by some or the other means. So I must have to choose my test by I can use this particular flowchart for choosing the test. I said that I need not have to think of what is my statistical hypothesis. Okay, I first of all I have to think of what I'm going to test, whether I'm going to test a difference, whether I'm going to test the association. So that is my basic difference and basic association. And then every research will have a combination of this. I may have some variables or some hypotheses which are testing differences. I may have some variables which are some hypotheses which are talking about association. So my hypothesis type has to be decided, and it should be, that is, the differences, or it is talking about either differences, or it is talking about association. So if it is of differences, then what is my next strategy for choosing my hypothesis? I have to think about my responses to my variables. That what response I am expecting, or the variables are measured on on what level the variables are measured. So whether they are measured on interval scale, or whether they are measured on ordinal scales, or whether they are measured in terms of certain as a categorical variables. So if it is a categorical variable, so definitely they are measured in terms of frequencies. That means I may be interested in number of males, number of females, number of people in certain age group. I may be interested in number of people with certain education level. So it is talking about frequency in that particular category. So it is together. I'm saying that either I'm talking about frequency, or I'm talking about categorical information, or that is I'm talking about some uh, b- nominal type variables. So these are the three names which we can have. Nominal ultimately results in frequency. Categorical ultimately results in frequency. So automatically I call those variables as a frequency variables, and then they are called as the frequency variables. Frequency variables are those variables which are in a study to talk about the weightage of that particular variable in the study. That means how many males and how many females. So whether if I suppose if I categorized a number of males and number of females, so at the first instance I will come to know that whether my number of males are more or females are more. So what I should have to do, whether the study requires equal number of females or equal number of males, or there should not be a significance of difference between the proportion of male and proportion of females. If the study, as I said, that my if my study is confounded by male and female, then definitely if I fail to identify my confounding variable, and if my confounding variable is a gender, and if I fail to identify that gender as a confounding variable, and if I'm if I am coming out with some samples which is having a more number of males and less number of females, so ultimately I am ending up with a biased conclusion, and that biased conclusion because of that confounding variables. So that means when you think this particular slides, if you go through all these slides, then you will understand that all these slides are talking about only research, how to choose the statistical test for research, and not from the, it is not designed from the perspective of a person who is taking a course in statistics. It is designed, this particular session is being designed from the perspective of the layman who is trying to understand statistics. So that's why his strategy should be, if I'm not knowing anything, at least I know that what I'm going to test, that whether I'm going to test the differences or whether I'm going to test the association. So on the basis of differences, if I'm talking about differences, then I can have a category of variables. So I can talk about measurement level of the variables. Now, if it is measured on certain unit of measurement, then it is either an interval or ratio scale. And if it is not, and if it is measured on some Likert scale parameter, then we call it as it is an ordinal type variables. Ordinal means I can put it in order, but I cannot find the exact difference. And it is very obvious that if suppose one particular product is bought in a house, and if there are two people in a house, one is husband and other is wife. So husband and wife, if you ask husband and wife, they will not say ki they both of them have a equal level of satisfaction. They will say that they are satisfied. But if you try to measure the satisfaction level by asking few more questions, that whether you like color, whether you like the how which feature you like, so you'll find that there you will get a difference in opinion about that particular satisfaction level. So it is very essential. And in that case, if I'm saying husband is saying that I'm satisfied at my satisfaction level is 5, and wife is saying my satisfaction level is 5, and if I calculate the difference between these satisfaction levels of 5 minus 5, mathematically the difference should be 0. But as Likert scale says that this difference will not be 0, and it will be other than 0. That means it is not exactly 0. And all such a variables where we will say that we are not able to get exact difference as a 0, then we call those variables as the ordinal variables. They may be a number, they looks like a number, but when taken for a calculation with their characteristics, then they will not result in 0, and all such variables we call them as ordinal. Only I can say that if suppose, other thing is that suppose one has rated his satisfaction level with a rate of as given a rating as 5, and other has given a rating of 4, and if I calculate a difference between 5 minus 4 on satisfaction level, still I cannot say that the satisfaction difference is 1. That's why when we are calculating a descriptive statistics for such a type of ordinal data, it is frequency is more very precise. Frequency based calculations are very precise calculation. I may think of calculation of median, and I may compare median. So I have to apply, I have to accept some different strategies. Now, once you have once you have taken, once you have understood that you are taking differences, and if your variable is of interval or ordinal type, and whether it is of frequency type, then next question arises that what I am going to test. Now, if it is of interval, I am talking about interval only. It is ordinal I have written, but ordinal cannot be a part of parametric statistics. We say that we are talking about interval or ratio scale variable only. We are going to talk about frequency only. We are going to talk about interval scale only, and we are going to talk about frequency. I have written ordinal because I just want to comment what to avoid. So if it is interval, then I can use the following test. Where if it is ordinal, then I have to think that the domain is different and domain is non-parametric. If it is frequency, then I can use directly the following test. And if it is in association also, if it is the interval, then I can go with the Carl Pearson correlation coefficient and simple linear regression models or multiple linear regression models. But if my ordinal variable, my variable is different and different than interval or ratio scale, then I have to think of some different types of regression models or different types of correlation statistics. So it is, please note, those who will refer these presentations, they have to take care very carefully. Whatever wherever I have written ordinal, we do not use. I'm requesting the host that before sharing, I will just send you a different presentation so that you can share them, so that in future if they are referring at any point of time, they will not be in confusion. So for interval, we are talking only about interval or ratio scale variables. We are only talking about frequency type variables, and we are not going to talk about test for ordinal data. That is not a part of discussion for this particular domain. But still, I have put it because I will comment on those simultaneously. So in interval and ratio scale, now I may think of that I number of variables is another very interesting uh, parameter which has to be considered before choosing any statistical test. And how many variables you are going to test? That means difference. Either I can test difference of one variable against one some constant. That is the one sample test. We call it as a one sample test. If I am testing a difference between two groups or two variables, then I am calling it as a two sample test. If I am testing a difference between for more than two samples, that means three variables, four variables, I want to compare a difference, then I call it as a more than two sample test. And I have listed my test accordingly. That t-test is a test which is considered to be a small sample test. Okay, but if you'll see nowadays, it has there is one assumption for the t, that t approaches to z in a large samples. Now, how much large sample I should have to consider? There is always subject or there is subject of discussion. What is the large sample? Now, most of the statistics books, they are saying that sample size greater than 30 is considered to be a large enough. Okay, so but I don't feel that there are few books, few references which I had gone through, and the references that says that if you have a sample size greater than 100, then you can use z test. But if you apply t test in that situation, the results of t test and z test will be almost same. That means you will not have any difference in the opinion or conclusion if you're using t test or z test for the large sample. That means t approaches to z in large sample. Now let us take a first case, one sample t-test. One sample t-test, you have only one variable. Now say for example, I'm studying a case and I want to find out profit. I want to find out the profit earned by uh, some group of businessmen and businessmen in 1920, and I have a list of businessmen. That is, some category of business is there, and I have to compare that it is more than some defined value. Let us say that it is more than some 500 crore. So some business houses I have listed out, and I have one value I have given, that is 500 crore. So I have some 10 business houses. So 10 business houses I want to compare against a value that is 500 crore. So I will list out the profit for 1920 for all the 10 business houses, and then I will compare that against this 500 value, and I will use one sample t test. So please note, those who are not noting it down, or those who can note, please note it down, that I'm not it is not available on my slide. If you want, I will put my content, some some notes on t test and all, so that material can be shared with you as an document instead of sharing these particular PPTs. So that is the case of one sample test, one sample t test. And similarly, I can use z test. So So Z test and T test they can use only. Difference between Z test and T test is that we have to think of sample size as large when sample size is large, but most of the softwares like SPSS they do not provide Z. They in their softwares they are only providing T test, and if you compare the results of T test, then that is sufficient. In the large sample even you can use a T test because as per the rules T approaches to Z in the large sample. So we can rely on T test, and if you know T test that is sufficient, because anyway at the beginning you just have to choose a test and software has to do the job. So most of the softwares which are used nowadays they are tested and verified. Their results are tested and verified, so we can rely on them very blindly. We can rely on them like SPSS is there, R is there. R is a free version. Excel is there. Excel is also tested version. So we can use this. We are going to talk how to calculate or how to use all these tests in Excel tomorrow. So one sample T test. Now, if suppose I want to compare the profit earned by certain business houses of America and India. So I have taken some companies which are listed in Indian market, and I can say that I can make a two groups of companies. One is Indian companies and other is a foreign company, and I want to compare the profit. So my hypothesis will be there is no significance of difference between the profits earned by companies in certain sector, let's say manufacturing, as with respect to as a company as an Indian or foreign. That means I want to find out that is there any significance of difference between the profit earned by Indian companies and foreign companies, whether the profit earned by foreign is more than that of Indian, or whether the Indian are more than that of American or foreign companies, or as such we don't have any idea, but only we can see that there is no significance of difference. So that is nothing but that test we call it as a two sample test, and two sample test, and it is testing the mean. And all these tests which we are talking about is to test the average or mean. It is not testing any other parameter. That means neither it is testing standard deviation, variance, or median. So we should be very precise that we are testing a mean. T is used to test the mean. Z is used to test the mean. ANOVA is used to test the mean. So that is the basic idea. Now that is a two sample, and I can use any one of these, that is T test or Z test, for comparison of two samples, and we call them as a two sample test. But when we are talking about two samples, uh, we also have to think of that whether my samples are paid or not. So paid sample is nothing but that means I want to compare before and after. That means I want to say that Indian business house profit. Now let us assume that COVID before and COVID after. That what is the profit of business houses prior to COVID? That is prior to 15th March and then after 15th March. So whether that profit has changed or decreased or increased, whatever I want to, whatever you want to. Accordingly, you will design your hypothesis, and we call that type of study as a paired study, where the variables are paired by a time, and time is nothing but prior to COVID and after COVID. So before after situation. So wherever you are finding some kind of pairing, it is expected that you should use a paired t test, but there is no paired Z test. So we have to rely on paired t test only. So that's why t test is if you know t test, your hub job is done when you are testing the differences. T-test will not work when you have more number of variables. That means now let us say that I want to compare the profit earned by business by companies in particular sector, say for manufacturing, and my comparison parameter is Indian continent. Then there's let us say that Asian companies, then European companies and American companies. Now I have three groups of companies, and which are listed in Indian, that is in Indian domain, which are listed in European domain, and which are listed in American domain. So I have taken the profit, and I want to compare those profit. That average profit earned by companies is whether there is significance of difference between the average profits earned by companies in these three different So there I cannot use t-test, because t-test can be used only up to two variables. There I have to rely on I have to proceed for the next, and we call it as analysis of variance, that is ANOVA test. ANOVA test is considered as extension of t-test, and it is in extension of independent t-test. So we can compare only if the groups are independent. You can observe that whatever groups I am forming, they are independent. That means companies which are in India, they are expected not to be there in the part of European. That means European listed in European domain, listed in Indian domain, and listed in American domain. So my listed indicates that it is, they are independent groups we are talking about. So we have to use analysis of ANOVA, and we will use ANOVA to test the significance of difference between the profit earned by these three companies. Now, what about frequency data in case of differences? So, if it is a frequency data, then my basic aim is to compare the proportion. And there are two tests which are used for testing the proportion. One is a Z test for the proportion, and other one is a chi-square test for proportion. For proportion, we don't have any assumptions to be tested. Only thing is that we should have some enough significant data in my sample or in my study, so that I whatever proportion I am calculating will be standardized. Let us say for example, 2 out of 5 is also 40%, and 20 out of 100 is also that is sorry, 2 out of 5 is 40%, and 40 out of 100 is 40%. But 2 out of 5, if 2 out of 5 people are saying, and if I'm saying that there is a 40% people are saying, then it is very that statement will not be it is not considered to be a very strong statement. But if 40 out of 100 people are saying, then anyone who is listening to that statement, he feels that yeah, 40 out of 100 people are saying, that means it is really impactful. So that means it is your sample should be very precise. Only suggestion, this suggestion, no, you will not find that these suggestions are present, but these are suggestions because when you are using Z test or chi-square test, because all these tests, understand, statistics is a game of numbers. So if you ask softwares to calculate any value, it will give you values, but ultimately you are the one who is interpreting it, and you have to justify your samples, you have to justify your results. And 2 out of 5 and 40 out of 100 makes a sense for justification, that 40 out of 100 I can justify, but 2 out of 5, anyone, if you say that only 2 out of 5 people were present, and two are saying yeah, it is very good or it is not good, so it is 40% people are saying good. So anyone who is listening to that, he will say that please add more people, you will require more samples to make a comment or very strong comment. So that's why the only suggestion for the frequency. And there are two tests which are used for testing the proportion. I may test Z test. Z test has a category of one sample proportion and two sample proportion. So I can use Z test to compare the proportion of one sample, as I used for one sample in mean comparison. Similarly, I have a proportion, and I can compare a population proportion against a sample proportion. And a chi-square test can be used to test the proportion by either by contingency table. Tomorrow we are going to deal all these tests in Excel, so I will definitely tomorrow session will give you more precise idea what we are talking right now. Today we are just talking about how to choose the test, okay, and how these tests can be chosen for the analysis. Now we will shift on the other domain, and that is the association domain. It also has the interval and ordinal. Ordinal is not part of this discussion, and frequency. So I mentioned interval, and in interval scale, the basic test which is used for testing is Carl Pearson correlation coefficient, which is very precise, very standard measure of correlation. And if it is a cause effect relationship, then it is a regression analysis we perform on the data, and we come out whether there exists a regression analysis. Tomorrow we will learn in Excel that how we can run this test and how we can conclude. So tomorrow we are going to put it in case studies. So those who are logging in tomorrow, so please log in using your laptops, because we are going like a hands-on session. So it is, I requested my host to that I will directly go on the Excel, so that can give idea that everyone can understand that how I can use Excel. Excel is very powerful tool for doing some basic analysis. Even there are some add-ons which can be used for analysis purpose. We will discuss that in detail. So in interval, and I want to test association, my test will be Karl Pearson's correlation coefficient. If it is an interval and my aim is to find out the cause effect association, my test will be regression analysis. And if it is a frequency data, then this is very obvious test that chi-square test is used to test the significance of association between some categories. Say for example, one very famous example I always give, and that is I take the example from biology, and I say that cancer and smokers, lung cancer and smokers has any association. So I designed my study accordingly. I try to find out what will be my study design. My study design is that I have taken smokers, I have taken non-smokers, and I have asked them to go for cancers. Other way around also I can design it. That means I will take cancerous patients, I will take non-cancerous, and I will identify how many of them are out of cancerous are smokers and non-smokers. Out of non-cancerous, how many are non-smokers and non-smokers, and I can write my hypothesis that there is no association between smokers, smoking condition, and cancer condition, and I can put my alternate as there is a significance of association, and we call this as a independency chi-square test of independence. There is no association or the attributes are independent, so it is one and the same, and we use chi-square test. Tomorrow we are going to deal with we are going to use Excel to understand this particular test whatever we have listed now. My next slide is obviously it is of course it is of thank you slide. So I request my uh, host to proceed for the next slide, and obviously it is a thank you slide. So it is if you see that if you have any problem you can write to me. My email id I will share my email id tomorrow. I will share my email id. Otherwise you can write to your host if you have any query, and if you want me to uh, say something tomorrow, I will put my comments tomorrow also. Thank you.
Yeah, yes, sir. Yes, sir. So we will have some small question answer session.
If you have a question answers, please tell me the questions. I am not able to see the
And
questions.
then we'll wind up, sir.
Is it on chat?
I will, one second, sir. I'll just add Sarita ma'am. She'll take over.
Hello, sir. Uh, the first question is from Dr. Jasminder Sidhu.
Can I see
She
the
wants to know
questions?
how to identify a dependent and an independent variable. Sir, can you hear me?
Yeah, I can hear you.
Yeah, the question was how to identify a dependent and independent variable.
Define.
How to
What is that?
identify a dependent variable and an independent variable.
Yeah, it is very simple procedure to identify dependent and independent variables. If you are able to find out that the variable is expected to change with the other variable, that means this is the only criteria, that any variable which is likely to change with respect to other variables, or if the value of other variable changes and if the change is observed in the first variable, then I call the first variable as a dependent and other variable as independent. So every independent variable, whenever I am saying that it is independent, it may be dependent in other case. So we should not be means it is not a category or precise category. It is a respective categories of dependent and independent variable, and strictly restricted only up to that particular study. So it may be independent in your study and it may be dependent in some other study. So that is the only way of understanding this dependent and independent. Any other question?
Yeah, another popular question is what is a two-tailed test?
Two-tailed test is one-tailed and two-tailed is actually two-tailed test and one-tailed test is identified on the basis of your null and alternate hypothesis. So if your null hypothesis is of no difference and alternate is of again significance of difference, that is equal to and not equal to, then we call it as two-tailed test. If it is your, let us say that A is equal to B and its alternate is A is not equals to B, then it is talking about two-tailed test. If it is, if my alternate hypothesis is either A is greater than B or A is less than B, then it is considered as a one-tailed test. So you will find a lot of literature, but this is the only way of identifying two-tailed and one-tailed, and it is really going to have impact not in a statistical choosing statistical test, but it will have impact in conclusion, because your p-value which is being compared in will change accordingly. In two-tailed, the critical region will be 0.025, and in case of one-tailed, it will be 0.05 when you are
Okay.
talking about alpha. So you don't have to bother about one-tailed and two-tailed at the beginning of research only. Okay, so that is your hypothesis can tell us about one-tailed and two-tailed. Thank you.
Sheetal ma'am has a doubt in this. Like, which level of significance we should use? 5% or 1%?
It depends on researcher that how he want to be, how strict he want to be. If you want to be very strict, then he can use 1% or more than that also, 0.1% also. That means if it is a very general rule is that if it is not affecting or if it is not life threatening conditions, then we can go for 5%. That means most of the social research or social research which is taken place, or customer research which is taken place, that can have a 5% level of significance. So you can go with 5% level of significance.
Another very popular question: what is the need for hypothesis and what does it reflect?
Pardon me.
What is the need of hypothesis and what does it
It is,
reflect?
no, I think in my discussion, if you go through my discussion, you will come to know that I talked about objectives, and I said that there are some objectives which are of analytical types and which some objectives which are of exploratory types. So if you are having exploratory type hypothesis, in that case you will not require any kind of hypothesis. But if you are putting an analytical means inferential, that you have certain assumptions and you want to test it, and then there is a need of hypothesis. Otherwise you can plan your research without hypothesis also. That means it is a very it is in India we are not practicing it, but we can think of that my study is not having hypothesis. So there are two types of studies. One is planned, the study is planned to derive an hypothesis, and other study is the hypothesis guided studies. That means one study concludes with hypothesis and other starts with hypothesis. So it is not necessary that you should have hypothesis for every objective. That's why we should be able to identify as an objective, as an exploratory and analytical. Then if your objective is of analytical type, then only it will require hypothesis. Otherwise it will not require any hypothesis. And hypothesis will guide your study, analytical study. So that's why it is very essential that all analytical studies should have hypothesis.
Uh, Another question Ms. Archana Agarwal has: alternate and null hypothesis can be used simultaneously in one paper. Is it allowed?
Can be used in,
Alternate and null hypothesis, is it allowed in one paper simultaneously?
no, they are always simultaneously. Okay. So null, there should be one alternate for every null, because when we are rejecting null, then there should be something to be accepted, or if we are accepting null, then there should be something to reject. So that means there should be one hypothesis which is placed against null hypothesis. Definition itself, it says that it is the hypothesis which is placed against null hypothesis either to reject or accept on the basis of rejection, sorry, acceptance or rejection of null hypothesis. That means that is it is a pair of hypothesis. It is, there should be alternate hypothesis for every null hypothesis.
Sir, thank you so much for this informative session. I would like to now call Sheetal ma'am back to conclude this session.
There is one question which is research end with hypothesis means example. Okay, I would like to take this question because it's very interesting question. Shall I?
Yes, sir. Yes, yes, yes.
Shall I proceed? Yeah, because sometimes when we are, it is mostly in social studies that suppose I went on certain. I want to understand some culture, and then what I do, I don't have any assumption at the beginning about that culture because I don't have any prior information, no prior studies about that particular culture. So what I will do, I will directly go and study that culture by staying in that particular society, and then I will frame some assumptions about that society. That means I have started my study, I explored information, I have analyzed. That is a truly a qualitative information, and I have collected my data. I have analyzed that data, and I framed some hypothesis from this thing. This type of studies are nothing but they are that is hypothesis concluded on the basis of hypothesis. That means study is ending with hypothesis. That is outcome of the studies. You have come out with some hypothesis, and somebody else may go and test it in the same kind of society. So that is the example of. Shall we end here? We will also take some few more questions tomorrow. So I will answer. I will just
Yeah,
go
yeah.
through all the chat, and I will identify a few questions which are very essentially to be answered, and I will come out with answers tomorrow.
So we just have a concluding note. We'll just have. Sir, on this ending note for such an insightful session, I sincerely thank you, sir, Dr. Mule, sir, for on behalf of Tilak College of Science and Commerce for accepting our invitation and rendering an outstanding presentation today, sir. We are very, very grateful that we can understand various concepts today of hypothesis testing, be it t-test, test, square test. I think your valuable knowledge in terms of, it was very clear how hypotheses of different in terms of association and differences, how are they compared and how they are in terms of analyzed and everything, sir. And today I feel, for every research paper, analysis of primary data has become very, very important. I think your session would have definitely rendered some help to our faculty members who has joined us all over India, sir, for us. So I really want to thank you, sir. I know tomorrow we'll have more of practical session where you will definitely teach us how to use it on Excel. I think it will be more fruitful for them, even more clarity in understanding the various tests that you have just given example, wonderful examples today, sir. Your expertise and knowledge has made this session very, very successful, sir. So we really want to thank you, sir, for the session today.
Thank you, ma'am.
Uh, few instructions
Thank you.
for the participants, as tomorrow is our last session. The main important session we have, we will do practical session that Mule sir will explain how to carry out in Excel. So I would request participants to please log in with a new link that we will send, and I think that tomorrow's session will we make it all these points, the test that as sir has told, more clear. So that is more important. Yeah. So winding up this such an insightful session today, I want to thank our principal ma'am, Dr. Anita Joshi ma'am, for her massive support that she has given, the whole team, Chanchal ma'am, Sarita ma'am. So by this I end today's session with a very happy note, thanking you all See you all tomorrow for an insightful session again. Thank you. Thank you.